Let's discuss common pitfalls and how to avoid them in .NET. So we will be covering race condition, deadlocks, and starvation. Race condition we have already discussed it multiple times, but we'll revisit it. So you can think of race condition as two people writing on same whiteboard at same time. So here on the right side you have example where we have increment method which increments a counter variable by 1000 each time it is called. So we have two threads T1 and T2, and we are starting thread 1 thread 2. So we are expecting the value to be 2000, but it won't be 2000 because the counter as we discussed earlier, counter plus plus is like equal to counter equal to counter plus 1. So we have to get value, we have to add value, then we have to set value. There are three things happening. This is not atomic code. So while getting value, it may get stale value from some other thread. So this is race condition. So to avoid that, we have log, monitor, mutex, etc. to avoid this race condition. Then we have deadlock. Deadlock is like analogy would be two people each holding one half a pair of scissors, refusing to let go while waiting for the other. So we'll see this example in Visual Studio. So here I have two locks. So deadlock, this is famous interview question. People may ask you to write a code where a thread or a deadlock would occur. So in this case, so what is happening? We have two locks, lock A and B. Focus on the order of the locks. So we have two threads, T1 and T2. So T1 acquires lock A, then sleeps for a while to simulate a delay, and then acquires lock B. A, B. Thread 2 acquires lock B and then lock A. So it is A, B, B, A. So what will happen? The thread 1 will acquire this lock A. Thread 2 will acquire lock B. Thread A, when it reaches here, log B, it waits for log B to be released because log B is already been acquired, right? So it will have to wait. And here thread 2 will wait for lock A. So both the threads are waiting for each other to release, like a scissor example, which we discussed. So we'll run this application. So what we should expect is thread 1 acquired lock A, thread 2 acquired lock B, and the program is not finishing. I'm running the application. So this is where both the threads are waiting for each other. You can see thread 1 acquired lock A, thread 2 acquired lock B. So this is about deadlock. So how to resolve deadlock? You have to basically be careful about the orders. You need to ensure that the locks are properly used. You should know why you are adding the locks. So this is not a good case uh, like A B B A. The order should be consistent. And then we will discuss about starvation. So starvation is happens when the thread waits indefinitely for resource. So analogy, we'll discuss analogy first. So to make it more clear. So a kid in lunch queue who always gets pushed aside by other. So it will never get a chance. So in threads we can set priority like high affinity and all. So those threads will take more CPU time compared to a thread which is a flow priority. So the starvation may happen. So so the starvation happens. We discuss about when the starvation happens, right? Often due to lock unfairness or aggressive resource usage of other thread, this may happen. So example would be a low priority thread trying to acquire lock that constantly being taken by high priority thread. Hard to demonstrate in simple example, but you can simulate it making one thread acquire lock repeatedly with thread.sleep if you want to play around with it. But solution would be to use fair locking mechanism, semaphore, mutex, or lock ordering. Avoid long held locks in high priority threads. This would be the solution to avoid starvation. So That's it from Deadlock, uh, race condition, and starvation perspective. Thank you. Thank you for watching this video. This video is from a course available in Udemy. The link will be available in description. In this course, we deep dive into .NET threading concepts like introduction, high level threading concepts, fundamentals of thread, when to use tasks, threads, async await, synchronization context, mutex, pin lock, auto reset event, and I have also provided link for GitHub, which is available. So here you can see, get the PPT as well as the codes which are used. This you can use for freely. Examples, I would encourage you to fork it and play around with it. And PPT, if you see example, I have used analogies to make things much clearer, like auto reset event can be considered as a turnstile, manual reset event can be considered as open gate, semaphore as a printer which is taking only for a few jobs, countdown event like rocket. So things you will remember for long time. The conceptually everything is explained properly. So please, if you have time, check my courses and check GitHub link. Thank you very much. Have a good day.